So today we're going to be wrapping up the final section for Chapter 1 test for my virtual class. So the final section is 1.10, and in particular is going to be linear equations. Now, we've worked with solving linear equations, solving for x and all that good stuff. However, this time it's a bit different. We're going to view them in a different way. We're going to view them graphically. And we're also going to figure out some properties of what they consist of and whatnot. So, our first definition we need to work with linear equation is going to be slope. So, definition time. The slope, and we're going to denote this with the letter m. That's the symbol we'll be using for slope. The slope m of a linear equation that passes through point, and then let's call this point, let's use a different color real quick, A, and then B. So we're going to use 2 points. I'm going to call the first point, the name of the first point is going to be A, and the location of point A is some x and y value. Then the location of point B, that's our second name, is located at some x and y value. But now there's an issue. Even though these have different names, their location is the exact same. I don't want that. So what I'm going to do instead is, while I'm working on this, I'm going to write down, I'm going to name the first points for A, x1, and y1. That denotes the first ordered pair, or the first location. And then for point B, it's going to be located at the second x value and the second y value. This is to cause less confusion when you're actually trying to work with these 2 points. I don't want you guys to assume that, hey, this x represents A or B. No, we should know exactly what we're talking about. That's why we give these names. So it's going to be a slope of m is going to be of a linear equation that passes through the points A and B, is going to give us passing the points A and B is exactly, let's now figure out what that means. We're going to have m is going to be denoted, or it's going to be equated to your rise over run. Your rise over your run. That is the idea of slope. Rise over run. Up and down, left and right. That's what you probably heard in middle school. Now, to actually calculate it out, if I gave you 2 points A and B, what you're going to be doing is, hey, well, you're going to be choosing an x or a y value initially. I don't know which one you want to start off. We're going to start with y2, just because we can. And I'm going to subtract that with y1. So I'm going to subtract the y value of my point B subtracted by the y value of point A. You're going to realize it doesn't really matter. You'll get the same results. It's just, this is a good way to organize things. And then the second point is going to be located at, not second point, I'm sorry. Your run is going to be calculated as x2 minus x1. So I'm subtracting the x term from the x point from your point B and the x coordinate for your point A. All right, great. Now let's do an example of what this means. Let's use the ordered pair 2, 3, negative 2, 3. And then we're going to use, let's call this point A. And then we're going to call this point B. Let's call point B 1 and, let's do 4. Put positive 4, but it's fine. We can see that as plus 4. So, to calculate my slope between these points, let's suppose line passes through. If my line passes through points A and points B, then the slope of that line is going to be calculated as, so slope, it's going to be calculated as, hey, let's choose the y value of point B, so that's 4, minus then the y value of point A. And the y value of point A is negative 3. I use parentheses so I don't make a mistake. And this is all going to be divided by the y value, or the x value of point B, which is negative 1, minus the x value of point A. And that is 2. Boom. So the idea is that you're getting the change in y divided by the change in x. The difference in your y values subtracted by the difference in x. So if I calculate that out, I get m is equal to 4. I can distribute this negative, or another idea of how you guys can imagine that is that we can always just turn subtract into addition. So this becomes 4 plus 3 all over negative 1 minus 2. And that's going to give us 7 over negative 1 minus 2. That is going to be negative 3. So this is your slope of your linear equation. Great. What does this tell us, though? So slope is a ratio between how much your graph will rise and how much it'll run. How much your linear equation will rise and how much it'll run. It gives you an idea of where the next point should be located. It's your rate at which your linear equation is going towards. So now we have the idea of slope. So we got to talk about how slope looks graphically. So if I have a graph, let's use black. We're going to have 4 graphs in total. So I'm going to draw the last one down here. And if you have a positive slope, let's say m is positive, this graph is the xy plane, your x and your y. Then a positive slope may look something like so. If I read it from left to right, it is increasing upwards. So imagine like a little roller coaster, and if you read it from left to right, that roller coaster is going upwards. It's climbing up a mountain or whatever it's doing. I don't know. And then a negative slope is going to do the opposite. In your negative slope, you're going to have your line go downwards. If you read it from left to right, you're actually going down that hill or that roller coaster. So what if your slope was 0? What if your slope was 0? M equals 0. How does that look? Well, if your slope is 0, you actually have a horizontal line. It is completely horizontal. And the last thing is, you have one last exception when no slope, or your slope is undefined or no slope. That's when you have a line that is perfectly vertical. So this is what your positive slope looks like. This is what your negative slopes look like. This is what happens if you have a slope of 0. And this is what happens if you have no slope. Now, you only get a slope of 0 if rise equals 0. If your rise is equal to 0, that's when you get a slope of 0. That makes sense, because 0 divided by anything is 0. Or, yeah, 0 divided by anything is 0. Now, you get no slope if you're dividing by 0. Not 0 divide a number, but you're dividing by 0 instead. Because you can't have a number divided by 0, then you get no slope. So it's a vertical line in this case. You're rising without even running, which that should already cause problems if you think about it. So now moving on. The slope is one of the most important things in mathematics you'll learn, next to finding zero/solution/ x-intercepts. They're the most important concepts, so we got to go into it. Now that we have slope, we can talk about linear equation representations. So there are 3 different representations for linear equations. 3 different representations that you need to know. The first one is going to be called point slope. That's the first one right there. Point slope. And this is going to be in the form of y minus... Oh, y minus y1 equals m times x minus x1. I don't like this color. Let's do, where's pink? Oh, and then let me color code some stuff real quick so you guys get a better idea. Actually, I'm still working on learning how to color code better. Boom. That is the point slope formula. So that's one. Point slope formula or point slope equation, either or. And then you have your slope intercept form. Slope intercept form is in the form of y equals, and then you have your m, and then the rest is x plus whatever your b term is. Y equals mx plus b in this case. And then the final one that you need to know is called the general form. And this is in the form of a, b, c equals 0, where you have x, y, plus plus. ax plus by plus c equals 0. These are all equivalent. They're all the same. However, they are just different representation. I might move the b term to the left side, or I might move the slope somewhere else. They're all equivalent to one another. It's just different representation. There are advantages and disadvantages of each. And I'll give you the hint. The name helps out. So, what is point slope used for? Well, you can, the pros of this guy right here, you can easily write equation. Linear equation with single point and slope. If you have a single point and I give you a slope, you can easily write an equation in point slope formula. Example. Let's say, I gave you the slope. Let's say slope is slope. Oops. It's equal to 2. And then, or through point 5, 6. Let's say I have a slope of 2 and my line passes through the point 5, 6. Well, if you use your point slope formula, the only things you got to plug in is the x and the y coordinate right here. I use ones to represent, hey, these are the things that we're changing. And then also your slope m. The other x and y, do not change that because we need to use those as placeholders for our equation. So what that means is you're going to be keeping that y over here. I'm going to use a different color. You're going to be leaving that y here, but then now we're going to use our y1, and this is our x1. So our y1 is 6, and then we're going to set that equal to whatever my slope is. It says here is 2, I'm going to plug in 2. Well, I keep that same x here because it doesn't have the subscript denoted with it, and then I subtract off my x1. That is it. So I have y minus 6 equals 2 times x minus 5. That is it. If I have a point and I have a slope, I can easily do point slope form. This is very powerful. for creating line. Equation. If you need an easy way to create the equation of a line, point slope is your guy. However, some instructors do not like their answers or equations in the form of point slope. They instead generally want you to put your equation in slope intercept form. Well, the key word in slope intercept is slope and intercept. So this right here needs slope and y-intercept. And what is a y-intercept? It's the place where the line touches your y-axis. So this is your y-intercept. This is your slope, of course. And then notice that the x and y does not have subscripts. So that means I keep them the same way they are. So example, let's say slope equals -1/2, and then y-intercept equals the y-intercept is located at 0,6. All right. Well, if this is the case, then your y-intercept is 0,6. So all I have to do is plug in my values now. So on the graph, it might look something like this is 0,6. And then you're going slope of -1/2, so you might be decreasing like that. Where if I go to the next point, I go down 1 and then right 2 units. We'll talk more about that in a bit. So the idea, if you want to write this in slope intercept, you're going to leave it as y equals, and you have your x. These are the values you do not change at all for your equation. But then your slope is -1/2, and then your y value is +6. You look at the y coordinate of the y-intercept. All of your y-intercepts will have an x coordinate of 0. However, the y values is what's important. So +6. And notice that, believe it or not, the slope intercept form actually got derived from the point slope form. If I use my points, point slope form requires a point and a slope. But if I use my y-intercept for my point slope and calculate it all and distribute, I immediately get this equation. So you can verify that if you want to. However, the b, you might not see a b, but that's going to be that constant that happens, which is m times x1. All right. General form now. General form is a bit strange because this is the one that's the least common at this course. You will see a lot of general forms once you go into Calc. I want to say 2, I believe it's 2 or 3, is where you talk about multi-dimensions. So, general form is generally used in calculus, but this is really good for higher dimensions. So maybe if you're working with a 4-dimensional space or 5-dimensional, whatever, that's when general form is very useful. An example, you might have, let's say you're working in a 3-dimensional space, but you want to have something called a hyperplane. Don't worry about these terminology, it's perfectly fine. But if you have a hyperplane in a 3-dimensional space, it's going to be a line. A line, pretty much. Or imagine like a sheet of paper being a plane. So it's going to be an example of 2x plus 4y plus 3 equals 0. So you don't have to worry too much about it for now, but it will come across in calculus. They call it general form because this is the general form of an equation. If you don't know, like, these are specific forms. However, every equation can be written in this form right here. Every linear equation. Now you can put it in slope intercept and point slope, but you have to do a lot of work for that. It's very specific. You need a slope. You need a y-intercept. However, with general form, you do not need anything at all. It's that arbitrary or that general. So those are the 3 forms, and we're going to be talking about some pros and cons of each. Point slope It's really good for creating the equation of a line, especially when you're given a point and a slope. Especially when you're given it. It's very easy to write. But the disadvantage of it is it's not simplified. If you notice, I have y minus 6 equals 2 times x minus 5. I didn't distribute. I didn't add the 6. I didn't solve for y equals. So when you put it in your calculator, it's very hard. Your calculator, if you use a TI-83, doesn't really have a good way to put your equation in point slope form. So that's the advantage of using point slopes. It's very powerful for just creating an equation. But slope intercept form, this is very good for graphing. And this is very universal. It's very universal. Like when people want their solutions for a linear equation, they generally want it in slope intercept form. And why? Because it's easy to check if it's correct or not. Whereas point slope form, I can have a different points that gives me the same exact equation, but it's hard to see what the right answer is if, let's say, a student uses the point 0 or 4, 6, and then uses another point 2, 3 for a different student. It's hard for me to compare their answers unless I actually distribute it out and solve for y. For slope-intercept form, a line will only have one y-intercept unless it's a vertical line. So it's very easy to check if it's the right answer. I don't have to do any calculations or anything like that. It's already simplified. It's solved for y. Y is by itself. So it's nice in that manner. It's very easy to grade with. So it's very easy for graphing as well. Because when you're graphing this, hey, I can just easily find the y-intercept and then put a dot at the y-intercept, in this case over here. And then I just follow along. General form is very good for higher dimensions. There's not going to be anything too specific in this class regarding general form, but you will encounter that later courses. So, next thing is, I told you that point slope is the most powerful one, but our answers are generally going to be in slope intercept form because you can only have one slope intercept form for a linear equation. You can have multiple different answers for point slope, which is the reason why it's hard to grade. So what you're going to be doing most of the time, you're going to have a question such as a line passes through points -3, 2, 4, -5. Write the equation. So a line passes through the points. Let's call this A. Let's call this B. All right, let's just give it names. Passes through these points. Write the equation of a line. Well, already I want the answers in slope-intercept form. However, that might not be the easiest. If you notice point A and point B, if I graph them, this is the XY plane. X, Y. X is always your horizontal axis, and Y is always your vertical axis. So -3, so we count these off. It's telling us point A is located at -3. So we go to the left side, 1, 2, 3, and then I go up 2. Up 2 right here. Oops. It's pretty bad actually. Up 2. And then B is located, so let's call this A, and it's located at -3, 2. And then B is located at 4, -5. 1, 2, 3, 4, 5. So this is not an accurate illustration, but I'm hoping everybody gets the point. This is point B, 4, -5. I have to figure out what is the equation for this line right here. Let me see. That's a good color. What is that equation? It's a straight line, even though it doesn't look like it because I drew it wrong. But what is the equation of that line? If I wanted to express this mathematically, this linear equation, what is it algebraically? What is it in slope-intercept form? And I want slope-intercept form because it's universal. So it's very hard to do slope-intercept form because I can't find the y-intercept easily. Now, if I look on this, I might say it's around here, but it looks like it might be a decimal. And it's very hard for me to decide what the exact decimals are. So instead of guessing what that decimal is and getting it incorrect, we can actually compute the slope and everything. So instead of using slope intercept, we're going to work with point slope, which we need our slope and a point. So need slope and a point. And point. Well, let's do that real quick. Let's figure out what the slope is first. Slope is the important part. So you need 2 points to figure out a slope. And if you remember, slope is your y2 minus y1 over your x2 minus x1. Well, if I actually calculate that out, let's call b with the second ones, I guess. The x2 and y2. So if we use that, we have the y2, which is negative 5 minus, right here, negative 5 is your y2, x2. And then we're going to call this guy over here y1, x1. So now I'm going to plug in y1, which is positive 2, all over your x2, which is 4, minus your x1, which is negative 3. And you see how I'm using parentheses? It's just very helpful. So now I can turn this to addition. I get negative 5 minus 2, which is negative 7, all over 7, which is equal to negative 1. Okay, so my slope is equal to negative 1. Great. Well, now I can almost plug into my equation. My point slope, all I need is a point and a slope, which I actually already have that, and I have a bit more. Point slope says we have y minus equals x minus, and then we have y1 m x1. These are the values we're going to be plugging in blue. So our slope is negative 1. It's a ratio, but let's calculate it out. So I divided negative 7 divided by 7, which is going to give me negative 1. If I do that, I get m equals negative 1. So let's put negative 1 here. Great. Now, I'm going to plug in everything that doesn't change. I need to figure out what x1 and y1 are. Well, believe it or not, it does not matter if you use this point or this point. You just need to use a point that is on your line. As long as the point is on the line, it'll give you the correct equation. As long as you simplify it, of course. But it'll give you the exact same equation. So we're still using point slope. Remember that. Point slope. Slope. So let's choose b to be our values. So x1, or let's look at a actually. x1 is negative 3, so minus 3. Boom. y1 is 2. There we go. Now let's simplify this all out. I have y minus 2 equals negative 1, x plus 3. This turns to plus. Boom. Great. So now this is in slope. Point slope form. However, the issue is there can be multiple different answers depending on what point you plugged in. And I need a way to have consistency. So I will require you guys to use slope intercept form for your answers. So how do you go from point slope? How to go from point slope to slope intercept? How do you go from point slope to slope intercept? Point slope is very useful for just writing the equation, but how do I go to slope intercept now? Because that's what I want the answers to be in. Well, it's actually just simplifying. If you simplify this as much as possible, solve for y. Solve for y. If you simplify this as much as possible and solve for y, then you're good to go. And when you're solving for this, I recommend, right off the bat, you distribute. That's what I recommend. If you add 2, some people do their algebra incorrectly, so just distribute so you don't make any mistakes. Let's distribute this out. If I were to distribute this out, I'm going to have y minus 2 equals negative x. Negative x minus 3. Great. Now I can add 2 to both sides. And then I'm going to get y is equal to negative x minus 1. So what does this mean? This means that my slope-intercept form is here. Your let's say your mx, your m is equal to -1, and your b value is -1. They're both the same there in that case. So if I wanted to graph this as accurate as possible on the xy plane, all I would need to do is first plot where your y-intercept is. Well, it's at -1. -1's over here. Y-intercept where it touches the y-axis. And then you're going to rise and run to the value of -1. That means if I go up 1, I'm going to rise up 1. However, because rising up is positive, I have to go to the left because running to the left is negative. Remember, going up is positive. Going down is negative. But if you went to the right, that's positive. If you went to the left, that's negative for running. Run, and this is rise. This is how it works. So I have to, as long as I calculate to -1, I'm good. So let's do rise up 1, and then let's run to the left 1. And if I do so, the slope becomes -1, and I have my second point right here. Boom. And then now I can draw a straight line adjoining these 2 points, and that'll be my linear equation. And that's exactly what it should look like. This was our rough drawing over here. It's not as accurate, but now I actually have a perfectly accurate illustration. Or not perfectly, but it's more accurate than the rough drawing earlier. Because the other one right here, I only have 2 points, and I draw a line between those. And I don't know if it touches the y-intercept properly. However, this one, there's no way I can miss that y-intercept. That was the first point I started on. So that covers y-intercepts, or slope, turning point slope into slope-intercept form. Great. Now we move into, where's it at? Let's see. We need to go through a few statements. So, what happens if, let's say, we have line or vertical line that passes point, let's say 3, 4. How do I write the equation of a vertical line that passes through the point 3, 4? Well, let's imagine this visually. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4 is all the way over here. Boom. That's where my point is for the line. Now, I have a completely vertical line. How do I write the equation of this line? That was a terrible choice in color, actually. How can I write the equation of this line right here? This is hard because you don't have a slope. So what do? Well, if you look at each individual points on this line, they all share something in common. If I look at this point right here, this is going to be located at, let's say, 3, 0. If I look at this point, it's located at 3, 1. And look at this point, it's located at 3, 2, 3, 3, 3, 4. What do you notice all these points have in common? The x value, or the first value, your x value is equal to 3. That is the equation. Vertical line. Is whatever the x value of your point is. If your point was 4, 6, you look at your x value and you just write x equals 4. It's that simple. It's going to share all of the same x value, so why not just write x equals this value? So that's what happens if you have a vertical line that passes through the point. Now, what about a horizontal line? Well, this actually makes more sense now, because if I have a horizontal line, let's say it passes through the point right here. This is 1, 2, so this is going to be located at 0, 2, and this is 1, 2, and then 2, 2. You'll notice that all of these values, we have 1, 2, all of these values on a horizontal line will be whatever the y value is. So in this case, we have y is equal to 2. That's our equation. And you can think about this because we have y. Well, what's our y-intercept? Our y-intercept is 2. This is in slope-intercept form. But then mx plus b, of course. But what's our slope? It's 0. And 0 times anything is gone. So we have just 2. Boom. Same thing. So that's what happens when we have a vertical line. That's what happens when we have a horizontal line. We can express it mathematically in an equation. So I encourage you to try some more exercise. So let's say, so this is an exercise. Write the equation of a line that passes through -3, -2, comma, -1, 5. That passes through these points. And I'm not going to label them A or B. You can do that. You can choose which one you want to be A or B. And you can choose which coordinate should be x1, x2. I mean x1 and y1. And x2, y2. However, just remember the x1 has to go with the y1. So if you put this one x1, this has to be y1. It cannot be y2. So as long as you don't mess that up, you should be good to go. So write the equation of a line that passes through these points in slope-intercept form. Now, real quick, we're going to talk about a general form example. General form. Form 2 slope-intercept. Let's suppose I wanted to graph something crazy like 4x plus 3y minus 2 equals 0. Let's suppose I wanted to graph that. However, I need my equation in slope-intercept form to graph it. It's very helpful if I know where the y-intercept is, and then I just follow rise over run, then I got my line. It's hard to do it in general form. It's very hard to do in general form. So we need to solve to turn into slope-intercept, to go to slope, intercept, solve for y. We got to solve for y. All right, we got to get this term by itself. So that means I need to move this guy. I need to move this guy. All right, let's move them out the way. We're moving them. Remember, we're not dividing them out. We're not multiplying. We're moving terms, which means it's all addition and subtraction. So let's move the 2. I'm going to add 2 to both sides. If I do that, I get 4x plus 3y equals 2. Great. Now I want to move this whole piece. Well, how do I move that piece? I am not dividing by 4. Instead, technically there's a plus here. I am going to subtract 4x to both sides. I'm not subtracting 4. I'm subtracting 4x. I want to move the entire term. I can't just move a factor. I cannot do that. I'm left with 3y is equal to, these two are not like terms, so they cannot combine. Boom. And then I solve for y. All I have to do now is divide both sides by 3. And when I divide both sides by 3, I divide everything by 3. But that is the exact same thing as saying y is equal to the first term divided by 3, and then plus the second term divided by 3. That is the exact same thing. And we know this is true because how do you add fractions with the same denominator? You put them together. You add the top. So I can go backwards. Boom. So now I have this. Now I have an idea of my slope. Slope is going to be negative 4 over 3, and then y-intercept is 2/3. So what does this mean? If I were to graph this out, this is a harder one to graph, but if I were to graph it out, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I'm going to plot the y-intercept, which is 2/3, so it's about right here. And now it's saying that, hey, this is negative 4/3. So I can go down, rise, or fall in this case. I can fall down 4. 1, 2, this is very hard to count actually. 1, 2, 3, 4. It's like somewhere all the way here. Down 4, and then I can go, oops, somewhere around there. But then I can go to the right 3. So around here. If I draw my line, ooh, well, that wasn't the prettiest line. If I draw my line, it should connect. Or I can connect the two dots together. Boom. It's a rough estimate, so. That's the general picture of your graph. It's harder to do this one because this is 2/3, but the idea is that, hey, right here, I need to understand that I can go down 4 and right 3. Alternatively, you can go up 4 and left 3 instead. So you have a choice. You can go up 4 and then left 3, 4, and then left 3. Because this is negative. Remember that. That's negative. Or you can go down 4 and then you can go right 3 to your next point. Starting from your first point, if you travel that distance and draw another point at that distance, then you can draw a line. Either or, you'll get the exact same line. And to showcase that, initially I went down 4 and then right 3. But if I went up 4 instead, 1, 2, 3, 4, and then left 3, it's somewhere around here. My graph isn't the best, but it does work out. So you have a choice. As long as it's negative, which means one of the directions have to be negative. All right, so now we can move on. Slope is a very important topic that you guys should definitely have a lot of practice on, so I'll be sure to, or the homework assignment should help you out with that. Then, if we move on, in particular, we talked about point slope, going to slope intercept. We talked about general, going to slope intercept form. I am not going to require you to go from slope intercept and go backwards. That is not a requirement from me. That's too much work. The final thing I want to talk about is the idea of, where's that? Parallel lines. And so this is the symbol for parallel and perpendicular lines. Perpendicular. Parallel lines and perpendicular lines. So, real quick, notice that, let's go on decimals real quick. You guys can see this, thankfully. If I were to go on decimals, this is the actual graphing calculator that you guys can use for your notes and everything. Now, I do not allow this on the test, but it's a very cool feature to just learn mathematics. So, let's say I had y equals 2x plus 3. That's one equation, one line. What if I instead had y equals, let's do 3x plus 3. Let's do y equals, zoom in now, 2.5x plus 3. And then, actually delete this one. Oh. Zoom in. Yeah, this is good. And then y equals 2.1x plus 3. Well, let's do plus 8. That's too far. 4. And then the last one we're going to do is y equals 2x plus 6. 2.5. Boom. All right. Take a look at the red equation right here. The red line right here. If you look at this red line, which one of these lines would you consider to be parallel? You might argue that, hey, it's either the purple one or the green one. It's very hard to tell depending on some problems. If I would just give you the graph, you would have to zoom out. If you zoomed in this much, it is really hard to tell which one is parallel. You would think the black line over here is parallel to the red line. There's only really one way to tell. Notice that when you're doing these lines, they're made up of two things: a point, which sometimes is the y-intercept, and the slope. Well, one of these features will affect how lines are parallel. And it turns out that, hey, if two lines are parallel, they have to have the exact same slope. So instead of looking at this graphically, you can look at the equation and figure out which ones are parallel. So this is in slope intercept form because you have to do that when you're graphing. The red line, the red equation, is parallel to the black one because they have the exact same slope, which is 2. Now, using that same concept, what about perpendicular lines? Perpendicular lines are lines that make right angles or they're inverses. So, if I have a slope, so we figured out that the constant doesn't really matter. It's really up to the slope with parallel lines. Same thing should be true for perpendicular lines. Well, how can I construct a line that is perpendicular to the red line? So I only have the red line. How do I construct a line that's perpendicular? Well, let's figure it out. It has something to do with slope. Let's do x plus 3. Where'd that go? Well, that one over here. I want to use a different color. Let's use blue. All right, that's x plus 3. Well, if I want it perpendicular, it's going to be somewhere where my cursor is making a line with. That'll make that 90-degree angle or a cross. I want to make a perfect cross, I guess, or a perfect plus sign. There you go. Somehow I got to get there. Well, y equals x plus 3 didn't do it. Well, let's go smaller. Y equals 0.1x plus 3. I'm very close, actually. Let's do 0.5. 0.5x plus 3. Oh, wait, that's super close. So it looks like it's almost there. However, if we now change it to I need to change these colors. Let's do purple. Boom. It's very close. It made an X, but it's almost there to a perfect plus sign. It's almost perpendicular. What if I do negative 0.5 plus 3? That looks like it's about perpendicular, but what do you notice about 2 and the slope negative 0.5? Is there any relationship at all? When you see it as a decimal, there might not be a relationship. However, if you see it as a fraction, you'll see something good or something useful. So, two lines are parallel. Two lines are parallel if slope is equal. That's the first one. Parallel if slopes are equal. And we can say that two lines are perpendicular if slope is, well, we had earlier 2 and negative 0.5. But what's negative 0.5 as a fraction? That's just 1 divided by 2, right? So if I write down negative 1 divided by 2, do you see the relationship? Technically 2 is represented as 2 over 1. What did I do there? I flipped or I reciprocate. So two lines are perpendicular if the slope is, well, it's also a different sign. This one's negative, so we got to say negative reciprocal. So not only, I spelled reciprocal wrong. Not only are you changing the sign of your slope, but you're also flipping it. You're also reciprocating it. So example, let's say we have y equals 3x plus 4. Find a line parallel and Find a line parallel and perpendicular to this guy right here. All right. Well, the parallel, this means parallel is going to be y equals, well, it has to have the same slope. Now, I don't want it to be the same line. I don't. So I have to change the constant. It doesn't matter what I change it to, though. I can do plus 8. This is going to be parallel. Now let's do perpendicular. Well, that's going to be y equals, I got to flip it upside down. And then I got to throw a negative. I got to negative reciprocate it. And then the constant does not matter at all. Boom. So the constant does not affect if it's parallel or perpendicular. So what does the constant even, what's the purpose of the constant besides your y-intercept? Well, what if I ask you instead, what is the equation of the line parallel to, let's say, 4x plus 6y minus 5 equals 0 and crosses through or pass across, doesn't matter, 5 comma 2. What about this one? If I ask you what is the equation of the line parallel to 4x plus 6y minus 5 equals 0 and crosses through the point 5 comma 2. Well, I know this means same slope. All right. But what is the slope of this equation? And what's the purpose of the constant? Well, it turns out the constant doesn't really matter for figuring out if the line is parallel or not, but it tells you which one of the parallel lines is the one you're looking for. And what I mean by that, in your problem, you might have a line like this, and the lines parallel could be here, here, here. There's a million different, there's infinite amount of different types. But there is literally only one that will cross through the point that you want. It'll probably cross through here. I don't know which one it is. But that's the idea of the constant playing a role in these kind of problems. It's really because of the point. So, when I'm solving this problem, I need to have the same slope as this guy right here. But I don't know what that slope is. It's not in slope-intercept form. You can't just say 4 because it's attached to the x. That's not how it works. It only works if it's in slope-intercept form. This general form does not tell you slope. So you got to solve for y and figure it out. So 4x plus 6y minus 5 equals 0. Let's solve for y. We want to solve for this guy. So I got to remove, so to solve for this guy, I got to remove this guy and this guy. So let's add 5 to both sides. I have 4x plus 6y equals 5. And now I'm going to subtract 4y to both sides. 4x. If I do so, I have 6y is equal to negative 4x plus 5. They are not like terms. And divide everything by 6. And if I split that apart, I get y is equal to negative 4 over 6x. And then plus 5 over 6. Which is the exact same thing as saying y is equal to negative 2/3 x plus 5 over 6. All right, great. So the slope here, so m is equal to negative 2/3. Good. Now, if it's parallel, it needs to have the same slope. So I am going to call this m1. And I'm going to call the slope that I need to be m2. I need m2 in particular to be equal to negative 2/3. Now, it needs to also pass to this point. I didn't use this guy at all through my entire problem. So how can I write the equation of the line parallel to the other line right here, but it also crosses through the point? Well, think about it. I have a slope now. I finally have a slope. Great. What else do I have that I didn't use? I have a point. Automatically, you should be thinking point slope. It's in the name, point slope formula. So point slope formula says y minus y1 equals m times x minus x1. Where if I plug in my values, y minus, what was my point? 5 comma 2. So I plug in the y value, which is 2, equals negative 2/3 times x minus 5. Boom. Now I got to solve it out. So I get y minus 2 equals negative 2/3. Distribute this guy out. x. If I multiply that out, that's plus 10 over 3. And then now I add 2 to both sides. You get y is equal to negative 2/3 x. Combine like terms. And in this case, 2 is also 3 or 6 over 6. I mean 3 over 3. No, 6 over 3, I apologize. So this is plus 16 over 3. Parallel to, this is going to be parallel to your point, or to your equation right here, your original right here. It's parallel to 4x, what is that, plus 6y, minus 5 equals 0, and through point 5, 2. It's parallel to the equation of this line right here, but it also crosses through the point over here that I want. Now, what if instead I ask you, instead of parallel, I change it to perpendicular? You only really have to change one thing. Now, you can't change it here. You cannot. You have to change it all the way up here, your point slope. Change it over here. If I were to ask you what's the perpendicular line, well, you're going to be using point slope still. So it's y minus something, y1 equals mx minus x1. You're still going to use the exact same thing. However, it's going to be y minus, and our point that we used was 2, but our new slope, instead of being negative 2/3, we got to put we got to reciprocate it and change the sign. So it's going to be positive 3/2 x minus 5. And then when we calculate it out, minus 2 equals 3/2 x minus 15 over 2. You add 2 to both sides. Combine like terms, you get 3/2 x. And then if I add this together, that's negative 11 over 2. So what I encourage you guys to try out, this is a little exercise before we call it a day. The last exercise I want you guys to try out, test if 6y minus 2x equals 5 and these two equations, 2x plus 6x, 2x plus 2y plus 6x equals 1. Test if these two equations are parallel, perpendicular, or neither. I want you guys to try that as a little exercise, and then I'll call it that. So hopefully you guys get the idea of the properties with linear equations. We have three main forms. We have point slope, three different representation. They're all equal to each other. It's just how we want to represent it. So you have your point slope, which is best used for creating the equation of the line. I would highly recommend that. Now, you might be able to use slope-intercept form to create the equation of the line if you have your y-intercept. If you have that, that is easier. Now, the problem about these two, you still have to figure out what your slope is at the end of the day. You have to calculate your slope before you figure out what the equation of the line is. So calculate your slope. Then I'd recommend using point slope. You can use slope-intercept form if you have a y-intercept. Afterwards, you have to put your equation in slope-intercept form. All of your answers and everything will be required to be placed in slope-intercept form. So even if I give you a general form, you have to solve for y and simplify it out. And notice that I did split the fraction when I had my general form. So if I have a general form like over here, even though I solve for y, I have to split up the fraction. I have to make sure that I know what my b term is and what my m term is, my slope. Boom. Then you guys had an idea how to graph parallel and perpendicular line. Parallel means the same slope. Perpendicular means negative reciprocal. And then you're asked to find a line that is parallel / perpendicular, but also crosses through that point. So you have to choose a specific parallel line out of the family of parallel lines. So So that is the end of that. So I will catch you guys later. Take care. Bye.